Hey guys, welcome to part 2 of my real traffic tutorial. In the first part we have set up a road network, we have built a simple crossroad, and in this part we take a look at the vehicles. All vehicles are managed by the transport object. Here you find functions for creating, loading and saving vehicles. So let's create a vehicle object. First we have to choose the vehicle type. There are several types available. Let's start with a normal passenger car. The sim creates a car object with several components: the chassis and the wheels. These are the containers where you can put in your model objects later. The dimensions of the car are defined by the position of the wheels. So if I, for example, move the rear wheel, the length is changed, or the width. If I move it upwards, the radius increases. Only the right wheels can be moved, the left ones will be adjusted accordingly. The front wheels can only be moved horizontally and vertically. They cannot be moved along the Z-axis because this is the origin of the car. In most cases you don't have to edit the car components, because there is a function to adapt the geometry from a car model that we assign here on the link box. So let's make an example car. Don't know if you know this internet page, DMI car models. Here you can find a lot of free car models. The quality of most models is mid-poly, but that's pretty good if you have hundreds of cars in your traffic scene. So let's take a normal passenger car. Let me show you how quick and easy a car setup is done using our free car rig helper. So let's open this downloaded LWO file. There is an option split selections. In most cases the splitting is done by material, and that is not a good choice for using the car rig helper. So uncheck this and you will get the car, all polygons in one object. First we have to scale the model to realistic dimensions. I don't know the exact dimensions, but I think the width should be about 2 meters, including the mirrors, and the length is about 5 meters. So this should be okay. So the next step is to move the car on the ground. You may put it a bit lower so you have an impression of tire pressure when the car drives on the ground. Okay, so next step is the car should point to the positive Z-axis. So let's turn it 180 degrees. So now choose car rig helper, and after a second the model is divided into a body object and the 4 wheels. So you can use the car rig helper also for other car rigging, for example the drive plugin or any other. So copy this one into your scene. And in the car model, you have here the source object link box. Just drop it here and press adapt geometry. And this is all. Now you have a new car in your traffic simulation. As you can see, the dimensions of the components are adjusted to the car model, and the car model is moved in a way that the front wheels are exactly on the 0 position of the z-axis. This is very important because this is the origin of all cars. Now let's add brake lights and turn signals. We use the add component function and choose from several types the brake lights. This component is a kind of control object. It switches the brake lights on when the brake is pressed, and the deceleration is higher than this threshold value. So we need an object that represents the luminous state of the brake lights. In most cases you will use a luminous material, but you could also use a real light object. So let's look for the real light objects. Since this model consists of only one object, we have to locate the appropriate polygons and split to a new object. We don't need all these materials. So let me create a simple luminous material. Maybe a bit of glow. And assign the material. So I move the object a bit so that it's on top. It's very similar with the turn signals. We get two components for controlling the visibility of luminous turn signals. And again, we have to locate the appropriate polygons. And split to a new object. Again, deleting the obsolete materials. Now we have both turn signals in one object, so we have to split it again. I make a copy and delete the wrong polys in each version. Now quickly a material by copying the brake lights and making it orange. Assign the material and move the object on top. Now we define our brake lights as the remote object. I uncheck the switch render visibility option because I want a bit of fading rather than a sudden switch. The value range can be left by 0 to 100%. This will control the visibility value of a display tag. Now to the turn signal components. As with the wheels, only the right object can be edited. The left one is set automatically, except of the remote link certainly. So let's assign our objects. The frequency of the turn signals can be edited here. The default value is taken from the German traffic law and should be good for this car. It's not necessary to vary this value for each car, because the simulation will slightly modify this value by random when the car is emitted, avoiding all cars blinking with the same frequency. Next we can make some settings for the chassis. Although there is no simulation of the suspension, we can make the body pitch and roll according to the acceleration and turning of the car. Therefore, the chassis component also provides a remote object link box. So we can assign the body of the car here. You have to play around with these values to find good settings for your car. The higher these values, the softer the suspension looks like. The body pitches when the car brakes and rolls when it drives through curves, depending on speed. So let's quickly step through the other functions and parameters. The type was set when creating a vehicle and cannot be changed afterwards, so it's just an info. The clone checkbox is set for all cars that are cloned by the simulation. If it is checked, you can uncheck it to make a clone an original. This topic is covered in the last part of this tutorial. The distribution rate defines how often a car is emitted in relation to other cars of the same time. So rare cars, for example a Ferrari, should have a low distribution rate. Use instances. This option helps to save memory. When a car is cloned for emitting, all polygon objects are replaced by instances, with two exceptions: if the object has a protection tag or a display tag. The Vary Materials options can be used to get different paintings for the car clones. I'll come to this topic later. Let's take a look at the intelligent driver model. These parameters are individual for each car. You can set the driving behavior between defensive and aggressive. The setting is reflected in the color of the chassis component, from yellow to red. Like in reality, aggressive drivers will change lanes more often and accelerate and brake stronger than defensive drivers. So you would probably make a sports car driving more aggressive than a family van. With a variation, we tell the simulation how much the value may be varied for the emitted clones. You should leave this value at 100%. In the transport object, we have the already mentioned exchange materials section. Here we can define several material groups for varying the materials of the clones to be emitted. Usually you will group here different car paintings. You can set up different painting groups, for example, quiet colors for luxury cars or bright colors for compact cars. You can also set up groups for interior colors or softer materials. So when the car is cloned, the simulation looks up in these groups. If a material of the original is present in a group, it will be exchanged by other materials of the same group. Next we have the Vehicle Geometry tab. Here you can swap the entire geometry of all your cars. If you have a lot of cars in your scene, maybe the simulation don't run in real time anymore. So just select the file name and click on Swap Vehicle Geometry. Only the components remain in the scene and you get back the real-time performance to work on your project. You can load back the geometry at any time when you want to render, for example. In the Global Driving tab, we find some global parameters for the intelligent driver model. Here you can set the target velocity, the maximum acceleration, and the comfortable deceleration for each vehicle type. These values define the driving behavior if there were no other cars ahead and no regulations like speed limits. I think the acceleration and deceleration default values are a bit too high. You may decrease these values in order to get a smoother traffic scene. The simulation supports voluntary and forced lane changes. Forced changes occur, for example, when selecting the proper lane for a turn. Voluntary lane changes are done if an advantage in getting ahead is expected. The advantage threshold defines how big this advantage in getting ahead must be to make a lane change. So the lower you set this value, the more lane changes will be done. The politeness factor is a further factor for the lane change decision. The higher the value, the more the drivers will consider the other road users. Or the other way around, the lower the value, the more selfish the drivers. The maximum safe deceleration is an important safety factor. If the rear vehicle on the target lane would have to brake stronger than this value, the lane change won't be done. Okay, this was the second part of the real traffic tutorial. In the first part we have built a crossroad, and in this part we have created a vehicle. In the next part we will add traffic lights and some more vehicles. We will define the traffic volumes and let the cars drive. Thank you for watching.